Hello, welcome all the students to this mathematics class. I'm Miss Vandana Gupta, Assistant Professor of Mathematics. Today we are going to see how to solve linear programming problem. So we are doing unit 2, that is linear programming problem, which is the part of section 2 mathematics of BCom course. Quickly we will revise certain uh, fundamentals from the coordinate geometry, which you have already studied in school days. So points to remember: every point on x-axis has its y-coordinate equal to 0, and every point on y-axis has its x-coordinate equal to 0. X-coordinate is the horizontal line and y-coordinate is the vertical line. They meet at the point origin. The coordinates of origin are 0, 0. X-coordinate is 0, y-coordinate is also 0. So all these things you already know. Then equation of x-axis. Equation of x-axis is y equal to 0. Equation of y-axis is x equal to 0. And equation of line parallel to x-axis is y equal to k, where k is a constant. Equation of line parallel to y-axis is x equal to k. See here. If I draw here, this is my x-axis, horizontal line. This is my y-axis. And this is the point origin where they meet. Okay. Suppose I want to draw a line y equal to 2. Okay, so where is y equal to 2? Look at on the y-axis, y equal to 2 is here. So this is the line which is y equal to 2, and this is parallel to x-axis. See here, k ka value is 2. So if this k is positive, the line will be above the x-axis. Suppose I want to draw a line y equal to -1. So -1 on the y-axis is below x-axis. So this will be the line y equal to -1. Okay, here k is negative, that is if k is positive, the line will be above x-axis, and if k is negative, the line will be below the x-axis. And what if k is equal to 0? If k is equal to 0, you will get y equal to 0. What is y equal to 0? It is the equation of x-axis. So that means when k is 0, the line coincides with the x-axis. Okay. Similarly, the equation of line parallel to y-axis, if you have to draw, then it will be of the type x equal to constant. Now, when I'm talking about the equation of line parallel to y-axis, the line can be to the right side of y-axis or it can be to the left side. We will not use the word above and below. We will use the word right side and left side. Suppose this is my x-axis, this is y-axis, this is origin. Okay, suppose I want to draw a line x equal to 4. Okay, x equal to 4. So what I will do, look at on the x-axis, where is my 4? It is here. So this line will be the line x is equal to 4. This line is parallel to y-axis at a distance of 4. Okay, so and because my 4k is positive, k is 4 here, which is positive, so the line will be parallel to y. It will be definitely parallel to y-axis, but it will be to the right side of y-axis. Okay. Similarly, if I want to draw a line x equal to -2, where is the x-axis? Where is -2? -2 is here. So this will be the line x is equal to sorry, it is here. So this is the line x equal to -2. Here k is -2, and because it is negative, the line will be to the left side of the y-axis. Okay. So equation of line which is parallel to y-axis is given by x equal to constant. If that constant is positive, then the line will be to the right side of y-axis. If it is negative, then the line will be to the left side of y-axis. What if k is 0? If k is 0, then you will get x equal to 0. What is x equal to 0? Look at here. It is the equation of y-axis. So when k is 0, line will coincide with y-axis or it will be y-axis. Okay. So this is what are just the revision of what we did in the school days. Now, sketching of the graph. Any equation which is of this type, ax plus by equal to c, where a, b, s, c are constant, it is a straight line. So if you draw the graph of such an equation, you will get a straight line. Okay, but if instead of equal, if you have this type of sign, greater than or equal to, or less than or equal to, so in this type of expression is not called as equation, it is called as inequation or inequality. So if you draw the graph of these inequalities, you will not get a straight line. You will get a region. Okay. So we will see how to draw the graph of this type of equation or inequality. Now, see, to draw any inequality or any equation, if you want to draw an inequality on the graph paper, or the region represented by this inequality, you will have to first draw the line. Okay, so you will have to if I want to draw this region on the graph paper, so I will have to first draw this line, ax plus by equal to c. Okay, now to draw a line, we require minimum 2 points on that line. Okay, so let us see that. You already know this coordinate axis. You know this first quadrant. In the first quadrant, both the coordinates are positive. In the second quadrant, first quadrant x coordinate negative, second y coordinate positive. In third quadrant, x and y both are negative. And in the fourth quadrant, x coordinate is positive and the y coordinate is negative. So you already know that. Now suppose I want to draw the line x plus y equal to 5. How will I draw this line? So to draw this line, I need minimum 2 points on this line. What I have to do, I have to prepare a table like this, x, y, and the point x, y. You give any value to x and find out the corresponding value for y. You can give any value, but for the sake of simplicity, I'm in the solution of, if I take x equal to 0, it becomes easy for me to calculate the value of y. So I'm giving x equal to 0, but there is no hard and fast rule as such. You can give any value of x. So when I give x equal to 0 here, I'll get y equal to 5. When I give y equal to 0, I'll get x equal to 5. So in this way, I have got 2 points, 0, 5 and 5, 0. These 2 points I have plotted here on the graph paper. See, this is the point x coordinate 0, y coordinate. This is the point 0, 5 and this is the point 5, 0. Now what you have to do is you have to join these 2 points and you will get a line. So this line, the equation is x plus y equal to 5. Now look at this line. This line divides the entire plane into three parts. What are these 3 parts? The points on the plane which lie on the line. Okay. The points on the plane which lies on the line. Second part, the points which lie above the line. This portion. Okay, which I have represented or I have denoted by blue arrows. Okay, then we also have the part of the region which um, you can say which belongs to the lower side of the line, this side, green color. Okay, so you can see here that if you take any point in this region and add its x and y coordinate, you will get x plus y greater than 5. So what we can say is the region above the line can be represented by the inequality x plus y greater than 5. Similarly, this region which I have denoted by green arrows, everything here, okay, is represented by the inequality x plus y less than 5. You may check here. You take any point in this region. For example, let me take a point here. What are the coordinates of this point? X coordinate is 1, y coordinate is 2. You put x equal to 1 and y equal to 2. You will get 1 plus 2, that is less than 5. So what we have observed, that all the points on the line will satisfy x plus y equal to 5. All the points which are above the line will satisfy x plus y greater than 5. And the points which are below the line, that means in this region, will satisfy x plus y less than 5. Okay. Now, if I ask you, what are the points which are given by the inequality? Let me say by the inequality x plus y greater than or equal to 5. Okay. Now, what is the meaning of this? X plus y greater than 5 and or equal to 5. Both will come in this. So what will be that reason? See, x plus y greater than 5 is everything above the line. Okay. X plus y greater than or equal to 5 will include x plus y greater than 5 as well as equal to 5. Now, greater than 5 means above the line, equal to 5 means this. So this will be all the points on the line, on this line as well as here. Okay, this portion. Similarly, if I ask you what is x plus y less than or equal to 5, if I ask you what is x plus 5 less than or equal to 5, less than or equal to 5 means in this less than 5 will also include and equal to 5 also. So that will be all the points below the line as well as on the line, on the line. So this will include all the points on the line and below this line. Okay, so you can represent it by, say for example, all the points on this line and below this line, they are represented by x plus y less than or equal to 5. In our linear programming problem, many a times we will be having this type of inequality, less than or equal to and greater than or equal to. Okay, so we have seen that how to draw a line on the graph paper and how to draw the inequalities on the graph paper. Then feasible region. What is the feasible region? It is the region from which if you take any point, it satisfies all the inequalities. Means feasible region is the common portion represented by the inequalities given. So for example, let us see what is the feasible region of, suppose I ask you what is the feasible region of x greater than or equal to 5 and x greater than or equal to 1. Suppose I ask you this, what is the feasible region of this? In the feasible region, what we will have to see? In this, you have to draw this, you have to draw this and see what is the common portion. मतलब कौन सा पोर्शन ऐसा है जिस जो इसको भी सेटिस्फाई करता है और इसे भी सेटिस्फाई करता है. So let us draw this. That is called the feasible region. So x is, this is x axis, this is y axis. 1, 2, 3, 4 and 5. Okay, let me just let us take this x less than or equal to 1 and x less than or equal to 5. Suppose we take this. Okay, so what is x less than or equal to 1? First draw this x equal to 1. X equal to 1 here. This is the line x equal to 1. Okay, and x less than or equal to 5 is this. X equal to 5. Now, where is the region x less than or equal to 1? X equal to 1 is this line. So less than or equal to 1 means all this. Everything to the left side of this line as well as this line. Okay, less than or equal to 5 is, let me use another color, everything on this line and to the left side. Now I want a common portion. Common portion मतलब जो ये भी satisfy कर रहा है और ये भी. So I have to see the part in which red as well as blue color is appearing. What is that? It is, let me use yellow color for that. So which part is there? Which part is common to both? It is this portion. Everything on this line as well as here. Okay, so that is a feasible region. Feasible region is the region in which if you take any point, that will satisfy all the inequalities. Now let us, I have drawn here some feasible regions. So the very important and very easy one I have drawn here. Feasible region given by x greater than or equal to 0 and y greater than or equal to 0. Okay, so x greater than or equal to 0, you know what it is. It is your x equal to 0 is your y axis, correct? So this is x axis, this is y axis. Okay, x greater than or equal to 0 means what? ये जो pink color से इस पोर्शन में x का वैल्यू ग्रेटर देन और इक्वल टू 0 रहेगा, यू कैन सी, एंड y ग्रेटर देन और इक्वल टू 0 कौन से पोर्शन में रहेगा, y greater than or equal to 0, it is in this portion. Okay, and I want the feasible region, मतलब जिसमें रेड कलर का एरो भी है और ग्रीन कलर का एरो भी है, so it is from here to here. If we use the yellow color here, so this is the feasible region. Okay, this one, it is given, that means basically it is the what x first quadrant. So in our linear programming problem, we will always have x and y values greater than or equal to 0. Means we have to restrict ourselves only in the first quadrant. Okay, it can be 0 also, so the points may belong to here or here, but not negative. We don't have to use these three coordinates. Okay, these three quadrants. So feasible region given by these two inequality is this. Okay, then the next one, feasible region given by x greater than or equal to 3 and y greater than or equal to 2. So first of all, we will draw the line x equal to 3. First, we will draw the line. Wait a minute. X equal to 3. Where is x equal to 3? X, this line. This is the line x equal to 3, parallel to y-axis. We want x greater than or equal to 3. That means what we want is everything on the line and to the right side. जो sky blue color से है. Okay. Then y greater than or equal to 2 is which line? Use different color. See, this one. Y greater than or, this is the line y equal to 2. Oh yes, y equal to 2. And y greater than or equal to 2 means where I am using this arrow. So which portion is common to both? It is from here to here, this portion. So this is my feasible region. Okay. So the blue, this light blue color is given by x greater than or equal to 3. This green color, light green, is given by y greater than or equal to 2. When you see the common portion, it is this color. Okay. When you combine these two colors, you get this. So this is the feasible region given by these two inequalities. Okay. Now, what is linear programming problem? A linear programming problem is the problem of optimization. Optimization means either maximize or minimize. This is a common name, common term used for maximization and minimization. So a linear programming problem is the problem of optimization of a linear expression in a certain number of variables, where the variables have to satisfy certain conditions, which are called as the constraints. And the expression which you have to maximize or minimize, that is called as an objective function. See, in any a business unit or in any factory, the purpose is to maximize the profit and to minimize the cost of production. Okay, so but the maximizing the profit cannot go, they need to have some certain constraint. They cannot ask the labor to work more than the required number of hours, or they cannot use a machine whose capacity is only to only that machine can, if it can only run for 5 hours, you cannot make the machine to run more than 5 hours. So there are certain conditions which are to be satisfied. So those conditions are called as a constraints. So basically a linear programming problem has got two parts. See here, this is a linear programming problem. So here you are maximizing this x plus 4y. This is called as an objective function. So whatever you want to maximize or minimize, that is called as an objective function, and it is denoted by capital Z. Okay. So this is an objective function. What is an objective function of a linear programming problem? It is a function which you have to maximize or minimize. But these are subject to, after subject to whatever is written, they are called as a constraints. These are the conditions which x and y variables have to satisfy. In every linear programming problem, these two constraints will always be there. If a linear programming problem is of maximizing or minimizing whatever, but these two constraints will always be there. They are called as non-negative constraints. Non-negative constraint meaning what? X and Y values cannot be negative. Non-negative. Okay. Non-negative constraint. At the most, X will be either 0 or greater than 0. It can take value 0 or greater than 0. Y also, but not negative. So these two constraints you will see it is there in all the linear programming problems. Now, what is the meaning of solving a linear programming problem? Solving a linear programming problem means what is the meaning of solution of a linear programming problem? So, solution of a linear programming problem means to find the values of variable. Means to find the values of variables x and y और जो भी वेरिएबल्स है आपके x और y दो ही है, दो से ज्यादा भी हो सकते हैं, but in your syllabus you will be having only up to 2 because you are having only graphical method you are going to use for solving the problem. Okay, in simplest method you may have more than 2 variables. So solution of a linear programming problem means to find the values of variables x and y which satisfies the given constraints, which satisfy the given constraint. Means x and y has to satisfy the constraints or the conditions what are given constraint, and also maximize or minimize जो भी है, maximize or minimize the value of minimize z, z means objective function. Okay, so by solution what we mean is solution of a linear programming problem is to find the values of x and y which satisfies the given constraints, means all the constraints x and y has to be greater than or equal to 0, and the other constraints also they have to satisfy, and also which maximize or minimize the objective function. So let us see how to solve this problem. I have taken a problem here. Maximize z equal to x plus 4y subject to the condition x less than or equal to 5, y less than or equal to 3, and then x greater than or equal to 0 and y greater than or equal to 0. So first of all, what we have to solve it by using graph. So we have to draw all these regions on the graph paper. I mean, we have to find out a common portion that is called the feasible region. Okay. So because of these two constraints, our graph should be in the first quadrant. So I think I've drawn this here. I'm not drawn. Okay. So, so let us draw it here. First constraint is x less than or equal to 5, y less than or equal to 3. So what we will do, x less than or equal to 5, x less than or equal to 5, y less than or equal to 3. This is what is, okay. And x greater than or equal to 0, y, these are our constraints, right? So because of these two constraints, we have to restrict to the first quadrant. Now, first of all, I will draw a line x equal to 5. Where is x equal to 5? It is this line, correct? I want x less than or equal to 5. So that means which region I want? This side portion, left side. Then y less than or equal to 3. Let me, this portion I need, this portion, okay? And I have to restrict only in the first quadrant. So I'm not going beyond this, okay? Then y equal to 3. So wait a minute. 1, 2, 3, 4. Okay. Y equal to 3. Where will be that? Here. Y equal to 3. This is my line. Y equal to 3. I want y less than or equal to 3. Means what I want is this portion below the line. Now I want a common region. So common region will be this. जिसमें blue color भी है and red color भी है. This is my feasible region. In this case, the feasible region has a boundary. So what are the points of the feasible region? Let us write down. This is the point O. This is A. This is B. And this is C. So OABC is my feasible region. Feasible region is OABC. Okay. OABC. Now what you have to do is the solution of your linear programming problem will be at any of these corner points. These are called the corner points. Okay. So let us write down the corner point, make a table like this. Write here the corner points and here you write the value of z. Okay. So what are the corner points? O, A, B, and C of the feasible region. What is Z? Z is x plus 4y. Z is x plus 4y. Okay, let us write down the coordinates of O. O means origin. Iske coordinates are 0 and 0. What are the coordinates of A? X coordinate is 5. This is 5 here. 5 and 0. A का coordinate है 5 and 0. What is the coordinate of B? B का x coordinate कितना है? 5 and y coordinate क्या है? 3. See, look at here. X coordinate of B is 5 and y coordinate of B is 3. So 5 and 3. B is 5 and 3. And what is C? C, this point is C. Iska x coordinate is 0, y coordinate is 3. So we have written all the coordinates of this. If you have graph paper, you can easily find out the coordinates. Now find the value of Z at each of these points. So here, when you put x equal to 0, y equal to 0, you will get 0. Here, x is equal to 5, put x equal to 5 and y equal to 0. So 5 plus 4 into 0 will give you 5. And here, x equal to 5 plus 4 into y is equal to 3. 5 plus 4 into 3. So 5 plus 12. So it is 17. And here Z will be x is 0, y is 3. So it will be 12. So we have find out the value of Z at each of the coordinate points. See here there are only 4 coordinate points. Different problems you will have different number of corner points. You may have 5, you may have 3, you may have 5, 6, any number. Okay, it depends upon your feasible reason. So our problem is what? To maximize Z. So what we have to do? We have to see where you are getting the maximum value. So where you are getting the maximum value? Here. This is the maximum Z. Okay. Here you are getting the maximum value. So the maximum value of Z is 17. And at which point you are getting 5 and 3. So what is the solution of this equation? This solution is, so solution of this linear programming problem, solution is x is equal to 5, y is equal to 3, and what is the value of maximum Z? When you put x equal to 5 and y equal to 3 here, you'll get 70. So this is the solution. X equal to 5, y equal to 3, and maximum Z is 17. See here, maximum Z is 17. So these x is equal to 5, y equal to 3, they satisfy all these conditions, and also your Z is maximum here. So this is how we solve the linear programming problem by using graph. Let us take one more problem of minimizing. See here, solve the following linear programming problem. Minimize, यहाँ पर आपको minimize करना है. Z objective function is 3x plus 2y and subject to these are the constants. As I told you, these two constants will always be there in the linear programming problem. See, if the linear programming problem is of minimizing, then the remaining constant will be of this type, greater than or equal to. But if the problem is of maximizing, then these constants are of the type less than or equal to. So that you remember. Okay, maximizing problem में ये constant less than or equal to form में रहेंगे, and minimizing problem में greater than or equal to form में रहेंगे. ठीक है? Now to solve this, again we have to first find the feasible region given by these inequalities. So here I have done that. See here, x plus 2y greater than or equal to 6. That is our first one. And 2x plus y greater than or equal to 6. Okay, so x plus 2y greater than or equal to 6. ये हमको region draw करना है. So first of all, we will have to draw the line x plus 2y equal to 6. How will you draw this line? You will put the value of x equal to 0 and find the corresponding value of y. When you put here x equal to 0, you will get 2y equal to 6. And so y is equal to 3. So the point will be 0, 3. Similarly, when you put y equal to 0, you will get x equal to 6. So you will get 2 points on the line 0, 3 and 6, 0. Okay. Let us plot these points on the graph paper. So 0, 3 means x coordinate is 0, y is 3. So x coordinate 0. So this is the point 0, 3. This is the point 0, 3. 6, 0. It is here. 6 and 0. Then I have joined these two. So this is this line. Okay. And we want x plus 2y greater than or equal to 6. That means this portion. Greater than मतलब line के ऊपर का portion. So this is what I want. This is the reason given by this line. I hope you have understood. Now let us draw the other reason. What is the other reason? The other reason is given by 2x plus y greater than or equal to 6. Okay. The other one is 2x plus y greater than or equal to 6. This one. So first I will have to draw the line. So let us make a table like this. Give x, the value of x as 0. So you will get y equal to 6. So you will get the 0.06. When you put y equal to 0, you will get x is equal to 3. So you will get 3, 0. Let us see where are these points. So 0, 6. X coordinate 0 and y coordinate 6. This is the 0.06. And where is the 0.30? It is the 0.30 here. Now what you have to do? Join these two lines, these 2 points. And you want this region. So it is above this line. So we have, and these two are nothing but your first quadrant. So now what you have to see, the common region. Okay, common region means the region which is the common region where you are getting red color as well as green color. So which is the common region? See, it is from here to here and here. Okay, so the common region is this one, from here to here and from here to here. So let us, I give a name to it, A, B and C. These are the corner points of this feasible region. This is my feasible region. Okay. The corner points are feasible region. The corner points are A, B and C. Now in minimization problem, because of these concerns greater than or equal to, we are taking the part which is above the line. So this will not be a bounded region. जैसे maximizing problem में हमको देखो इस तरह का region आया था, ये देखो ये bounded था पूरा, इसको पूरी closed boundary थी. लेकिन minimization problem में you may not get a closed boundary. ये देखो यहाँ ये region is unbounded. देखो so but still we have the common corner points A, B and C. Okay, so what we will do? So we'll make a table like this. We know that our solution will occur at the corner points. Okay, so we will write down the corner points. Corner points of the feasible. Once we have drawn the corner points, I mean the feasible region, almost your problem is complete. Now you will find out the value of Z here. Value of Z. Z is what? Z is 3x plus 2y. 3x plus 2y. Okay. So what are the corner points? They are A, B and C. Write down the coordinates of A, B and C. What is A? A का coordinate है 0, 6. B का क्या है coordinate? X coordinate is 2 and Y coordinate is also 2. B is 2, 2. B is lying on both the lines. So it is the intersection point of both the lines. So that is 2, 2. Okay. 2, 2 and 6, 0. B is 2, 2. C is 6, 0. And what is A? A is 0, 6. 0, 6, 2, 2 and 3, 0. No, this one 6, 0. 0, 6, 2, 2 and 6, 0. 0, 6, 2 and 6, 0. Correct? Yeah. 0, 6, 2, 2 and 6, 0. These are ABC. Okay. Now you have to find the value of Z at this point. So at the point 0, 6, put x equal to 0, y equal to 6. So you will get 3 into 0 plus 2 into 6. What will be that? It will be 12. Here 3 into 2, x ka value 2 and y ka value is 2. So 6 and 4, you will get here 10. Here x ka value 6, y is 0. So you will get 80. Now your problem is to minimize Z. So where you are getting the minimum value? Here Z is equal to 10 and it is for 2, 2. So what is the solution of this problem? So let us write down the solution. So solution is what? Solution is occurring at which point? 2, 2, 2 पे. आपका solution कौन से point पे आ रहा है? इस point पे आ रहा है 2, 2 पर. क्योंकि इसी point पे आपको minimum value आ रहा है Z का. So solution is x is equal to 2, y is equal to 2. And what is the value of minimum Z? Z is what? 10. At this point, the value of Z is 10, which is minimum. Okay. So we have taken one problem of to maximize the objective function, the other one for minimizing. Okay. Remember that to solve any linear programming problem, you have to first draw a feasible reason. Okay. Means find out the common portion. These two, because of these two constants, your graph will be always in the first quadrant. You may have more, यहाँ मैंने दो ही दिया है, you may have more than two also. So you have to see the common portion. Once you get the feasible reason, the next thing is what? To find out the corner points. When you got the corner point, the coordinates of the corner point, make a table like this. Write down the corner points and the value of Z here. If the problem is of maximizing, choose the value which is maximum. If it is of minimizing, select Z where you are getting the minimum value and see for which point it is. And the x coordinate of that point will be your value of x, y coordinate of that point will be the value of y. You can take this problem for your practice. Okay, minimize Z 10x plus 7y subject to these constants. I have done it here. Then one more problem, maximizing. You may practice them at home. So thank you.